It's a common story. You build an AI application, maybe a retrieval system, something based on your own data.
Yeah.
And, well, it just doesn't quite work reliably, does it?
Oh, yeah. That initial excitement hits reality fast.
Right. It makes things up, hallucinates, as they say, or it just completely misses information.
Yeah.
Is in there. It feels brittle.
That's the classic failure point. And honestly, the big lesson everyone learns moving past a simple demo is that basic RAG, Retrieval-Augmented Generation, it's kind of stupid. It's just too simple for the real world.
Exactly. So welcome to the deep dive. Today, we're going past that frustration. We're digging into some really solid source material that lays out 11 advanced RVig strategies.
Strategies designed to fix those exact real-world problems.
Our goal here is to give you the roadmap, the sort of strategic stack you need to turn that brittle demo into something genuinely production-ready, something that actually delivers reliable value.
Okay, so maybe let's quickly set the stage. What is this naive RAG we're talking about?
Good point.
It's really a simple pattern, 4 steps. First, you chunk your documents. You just chop them up into pieces.
Usually based on some arbitrary token count.
Right. Then you embed those chunks, turn the text into vectors, numbers basically, so a computer can search for meaning, not just keywords.
Like giving each piece of text an address on a big map of concepts.
Exactly. Then, step 3. Retrieve. You search that map and grab the top few chunks, maybe 3 to 5, that seem closest to the user's query vector.
And finally, generate. You feed those retrieve chunks, plus the original question, to a large language model, an LLM, and ask it to synthesize an answer.
Simple pipeline.
Simple, but like we said, deeply flawed when things get complex. Okay, let's unpack why. Why does that simple process just fall apart so quickly in the real world? Especially with messy data like internal reports or legal docs.
Yeah, it boils down to about 4 major failure points that really tank the quality. First off, the retrieval quality itself often just isn't good enough. That semantic search, the vector search, it's fast, yeah, but mathematically pretty simple. It's just looking for closeness in that vector space. So it can easily miss the actual best answer if that answer happens to rank, say, 7th or 8th, and you only ask for the top 5. The system doesn't even see it.
Wow. So the perfect answer might be sitting right there, just outside the window you chose. That feels like incredibly inefficient.
It is. And second, there's the huge problem of context fragmentation, that arbitrary chunking we mentioned.
Yeah.
It's like putting a crucial document through a paper shredder. You destroy the connections, the relationships between sentences and paragraphs.
What's the biggest threat from that context fragmentation? Like, what's the real damage?
You lose the full meaning because vital connecting sentences get separated.
Can you give an example?
Sure. Imagine a contract chunk says, the penalty is 10%. Sounds clear, right? But the sentence right before it, which defined whether that 10% applied to gross revenue or net profit, that got chopped into a different chunk. So the retrieved answer, the penalty is 10%, is now totally useless, or maybe even dangerously misleading because the defining context is gone, shredded.
Yikes. Okay, what else?
Third, queries are ambiguous. Users don't always ask perfect questions. They ask things like, tell me about Q3 performance.
Right. Vague.
And the basic RS system has no idea what that really means. Should it check the financial database, sales reports, customer support tickets? It just kind of guesses or defaults to one source, often missing the bigger picture.
And the fourth failure point.
Finally, responses lack verification. The LLM generates its answer V1, and that's it. There's no built-in step for it to pause, double-check its work against the retrieve sources, or verify if it's even fully answered the question. It just spits out the first thing it comes up with.
So just to recap that retrieval point.
Yeah.
Why does that simple retrieval process often fail?
Because the initial search just matches words or concepts. It doesn't confirm semantic completeness or context.
Okay, that paints a pretty clear picture of the problem. The good news, as you mentioned, is we have strategies. We don't need all 11 at once, right? We need the ones that give the most bang for the buck first. Let's talk about that baseline stack, the things you really should implement.
Absolutely. And the first one, strategy number sewn in the source material, is context-aware chunking. This directly tackles that paper shredder problem.
Okay.
Instead of just blindly chopping text every, say, 512 tokens, you chunk intelligently, you respect the document's structure, paragraph breaks, section headings, maybe even bullet points.
That seems so fundamental. It feels like it should be table stakes for any serious RG system. Minimal effort during the initial data processing, the indexing phase.
Yeah, relatively minimal upfront effort.
But it ensures that when you retrieve a chunk, It's actually a complete thought, a coherent piece of information.
Exactly. It pays huge dividends down the line. Though, we do sometimes see pushback because it does add a little complexity to that initial data processing pipeline, the ETL.
It's an extra step, yeah.
Yeah. It's a necessary headache, maybe, but still a headache for some teams.
All right, what's next in the baseline? This is where, for me, it gets really interesting. Strategy 1, re-ranking. The source calls this the easiest win, highest ROI for lowest effort.
Oh, absolutely. Re-ranking is fantastic. It's a clever two-step process that balances speed and accuracy.
How does it work?
So, first, you do your standard, fast, broad semantic search. But instead of grabbing just the top 3 or 5, you grab more candidates, maybe 20, maybe 50, cast a wider net initially.
Okay, so you get a bigger pool of potential answers.
Right. Then you take that smaller pool of candidates, say 50 chunks, and you use a second, different kind of model. This one is slower, but much, much smarter at judging relevance. It's often called a cross-encoder.
A cross-encoder. So it rescores just those top 50.
Precisely. It looks at the query and each candidate chunk together and gives a much more nuanced score of how well that chunk actually answers that specific question. Then you take the top, say, 5 from that re-ranked list.
Wait, hold on. If that cross-encoder is so much smarter, why not just use it for the initial search across the whole database? Why the 2 steps? What's the catch?
The catch is computational cost and latency. That cross-encoder is slower and way more expensive to run because it does that detailed comparison of the query against each chunk.
I see.
Trying to run that super detailed comparison across potentially millions or billions of chunks in your whole knowledge base, it would take forever and cost a fortune.
Okay. So the first step is fast and cheap to narrow it down. The second is slow and smart for the final selection.
Exactly. Wide net first, then precise judgment. That's why it's such a big win.
So why is re-ranking considered non-negotiable then?
Because it beautifully balances that initial search speed with much higher final accuracy. Best of both worlds, really.
Makes sense. What's the third piece of this baseline stack?
Third baseline fix is strategy 5, query expansion. This one really helps deal with those vague or just poorly phrased user questions we talked about. Super common in things like customer support bots.
Right. How does that work? Does the system just guess related terms?
Kinda, but it uses an LLM to do it smartly. The system takes the user's simple query, like reset password, and it uses an LLM to brainstorm related searches. Things like account recovery steps, forgotten password help, changed login credentials, maybe even common misspellings.
So it runs multiple searches in parallel based on these expanded terms.
Exactly. It anticipates the different ways a user might phrase the same underlying need. It catches variations in vocabulary, jargon levels, all that stuff. Hugely valuable for improving recall, making sure you find relevant stuff, even if the user's wording isn't perfect.
Okay, that baseline stack, context-aware chunking, re-ranking, query expansion, seems really solid. High impact, relatively low complexity compared to what comes next, I imagine.
That's right. Those 3 should probably be in 80% or more of production RAG systems. Now we move into the medium cost, medium complexity solutions. These start tackling more specific thorny problems, but yeah, they cost more, either in compute time or setup effort.
Let's hear them.
All right, first up in this tier is strategy 4. Contextual retrieval. This is interesting. Instead of just improving the search, this one enhances the chunks themselves during that initial indexing phase.
Enhances the chunks. How?
So when you're first processing your documents and creating those chunks, you don't just index the text of the chunk itself. You also use an LLM to generate a brief summary of the text immediately surrounding that chunk, the sentences before and after it.
I see. So the chunk carries a little bit of its original neighborhood with it.
Exactly. So maybe you have a chunk that's just the sentence. The acquisition closed in Q4. During indexing, you generate a little summary of the paragraph it came from, like, this passage discusses TechCore's 2024 acquisition of data systems. And you store that summary along with the chunk's vector.
Okay, that makes a lot of sense. You pay a higher cost once up front during indexing because you're running an extra LLM call for every single chunk.
Right, it's a one-time cost per chunk.
But then forever after, when you retrieve that chunk, it comes with richer context. The search itself might even use that summary. I could see how that would really help, especially for dense documents where context is everything. For high-value, relatively static knowledge bases, that seems like a worthwhile investment.
Definitely. It provides much better context to the final generation step. Okay, next up, strategy 2. Agentic RAG. Now, this is where the complexity really starts to ramp up.
Agentic RAG sounds sophisticated.
It is. Instead of just running that single linear pipeline retrieve, then generate use an agent. An agent is basically an LLM tasked with reasoning about the user's query and planning a sequence of actions.
And so it doesn't just search once, it plans multiple steps.
Correct. Think back to that Q3 performance question. A basic RAG might just search the sales reports. An agentic RAG might reason. Okay, to answer about Q3 performance comprehensively, I need to first check the financial database for revenue and profit figures. Then I need to check the sales reports for regional breakdowns. And then I should check the customer feedback summaries for sentiment analysis.
Whoa. So it orchestrates a multi-step, multi-source search strategy.
Precisely. It breaks the problem down, executes the steps, maybe even synthesizes the findings from different sources. It's incredibly powerful for complex questions that require pulling information from multiple places. But
there's always a but.
It's a nightmare to build and debug reliably. Honestly, I still wrestle with prompt drift myself when I'm debugging these agent chains. It's tough.
Prompt drift. What do you mean by that? Does the agent just forget what it's doing halfway through? Can you give an example of a failure you've seen?
Yeah, it's kind of like that, or it gets stuck in loops, or its reasoning goes off the rails. The worst I saw recently was a circular dependency it created for itself. It was supposed to check document A, then document B, then combine facts.
Okay.
But based on some subtle nuance it picked up from document A and maybe its internal state from a previous turn, it decided document B contradicted A, even though it didn't really, hallucinated a reason why checking B was unnecessary, and then just skipped it entirely. And the whole time, it outputted this perfectly logical-sounding step-by-step reasoning for why it was skipping B. Debugging the agent's reasoning process is so much harder than debugging a simple linear pipeline where data just flows from A to B to C.
That sounds incredibly frustrating. So how do we avoid over-engineering with something like an agent? When should we actually use it?
My advice: skip agents entirely unless your user's questions genuinely require that kind of multi-source lookup and multi-step reasoning. If a simple retrieve then generate works 90% of the time, adding an agent is probably overkill and introduces more problems than it solves. Use it only when the complexity is truly warranted.
Okay, that's a crucial reality check. So we've covered baseline, we've covered medium complexity. What about the really high-stakes situations? Medical diagnosis aids, financial compliance checkers, legal discovery, places where getting it wrong is really bad.
Right. Now we're into the heavy-duty, specialized techniques. These often come with significant costs, usually in latency or computation, but they're designed for maximum accuracy and reliability. Strategy 10 is self-reflective RAG.
Self-reflective? The AI checks its own work.
Pretty much. This is a direct assault on hallucinations and incomplete answers. After the LLM generates its initial response, answer V1, the system doesn't just return it. It forces the same LLM, or maybe another one, to critique that answer. It asks specific questions like, does this response fully address the user's original question? Is every statement in this response directly supported by the retrieved source documents? Are there any unsupported claims?
Wow. And what happens if the critique finds flaws?
If the AI self-critique says, no, this answer is incomplete, or this claim isn't supported, the system forces it to regenerate the answer, taking the critique into account. It iterates, creating answer V2, maybe even V3, until the answer passes the self-check.
That's potentially huge for accuracy.
But the trade-off must be cost and speed, right?
Yep.
You're basically running the LLM generation step 2 or 3 times per query. Exactly. It can easily double or triple your LLM costs and latency per query. It's a very direct trade-off. Are you willing to pay significantly more for each answer to get that extra layer of verification? For high-stakes applications, the answer might be yes. For a casual chatbot, probably not.
Accuracy versus cost and speed. A classic engineering dilemma. What else is in this high-stakes category?
Strategy 9 is hierarchical RAG. This one is aimed squarely at dealing with truly massive document collections. Think millions, maybe billions of pages, like a giant legal archive or a comprehensive scientific library.
Okay, how does hierarchy help there?
Instead of just chunking everything into small pieces, you store information at multiple levels of granularity simultaneously. You might have the full text of a document, but also pre-generated chapter summaries, section summaries, maybe even paragraph summaries, all indexed.
So you have different zoom levels of the information.
Exactly. When a query comes in, the system can be smart about where to search first, a broad, high-level query. Maybe it just searches the chapter summaries first. That's much faster than searching millions of tiny chunks, a very specific detailed query. Okay, then it drills down to searching the individual chunks within the relevant sections.
It searches the appropriate level of detail.
Mm-hmm.
Saves a ton of computation on broad queries, I imagine. But that sounds like a nightmare to manage. Keeping all those summaries, chapter, section, chunk, perfectly in sync when the underlying source documents get updated.
Right.
Must be a huge challenge, right?
Oh, it's a massive indexing and maintenance challenge. You absolutely need sophisticated tooling and really careful pipeline orchestration to keep that hierarchy consistent. It's not trivial.
But the payoff?
The payoff can be huge for performance at scale. I mean, whoa, imagine scaling this to handle like 1 billion queries a day across an entire national archive or something. That level of nested detail combined with the efficiency, it's pretty incredible what becomes possible.
Yeah, the scale is mind-boggling. Okay, is there one more? You mentioned 11 strategies.
There is. The final one, strategy 11, often considered the expert mode or the final boss of RAG optimization, fine-tuned embeddings.
Fine-tuning the embeddings themselves.
Right.
Not just the LLM, but the model that creates those vector addresses.
Precisely. So instead of using a general-purpose embedding model that was trained on, like, the whole internet, you take that model and you continue training it. You fine-tune it specifically on your documents with your domain-specific jargon and nuances.
You teach it what acronyms mean in your context.
Exactly. You teach it that MI means myocardial infarction in your medical documents, but it means Michigan or management information in your logistics database. The general model might get confused, but a fine-tuned model learns the specific language of your world.
That sounds incredibly powerful for specialized fields, but also expensive and difficult.
Very. You need a high-quality data set for training, which can be hard to create. You need significant machine learning expertise on your team. And you need the computational resources for the fine-tuning itself. It's generally only worth it for large organizations with really unique, high-value knowledge domains where the general models just fundamentally misunderstand the terminology.
Okay, wow. That's a lot of ground covered. From simple fixes to highly complex, specialized solutions. So let's bring it back to the listener. If you're building production RAG system today, what's the takeaway? You clearly don't need all 11 strategies. How do you choose?
That's the absolute key takeaway. You need a strategic stack, not just a grab bag of techniques. For probably 80% of applications out there, that baseline stack we discussed is going to be your workhorse and give you the best ROI.
So start with context-aware chunking.
Yep, re-ranking.
Definitely.
And query expansion, get those 3 right first. They address the most common and impactful failure modes of naive RE. And then only add the heavier, more complex solutions like Agentic RAG or self-reflection or fine-tuning if and only if you've clearly measured a specific failure point in your system and you know that one of these advanced techniques is specifically designed to fix that problem. Don't add complexity for complexity's sake.
That leads perfectly into the traps to avoid. The common mistakes people make when trying to improve their RAG systems. What's the first big one?
Trap number 1, over-engineering on day 1. Just like we said, don't try to build the Starship Enterprise when a reliable shuttlecraft will do. Don't implement all 11 strategies right out of the gate. Start simple, get that baseline working well, especially add re-ranking early. It's such a big win, and then iterate based on observed problems.
Makes total sense. What's trap number 2?
Trap 2, ignoring evaluation, or as the source material nicely puts it, flying blind. You absolutely cannot improve what you don't measure. You need metrics. The best practice is to create a gold standard evaluation set. Maybe it's 20, 30, 50 really hard representative questions where you know what the correct answer should be based on your documents.
Like a final exam for your RAG system.
Exactly. And you run your system against that test set before you make a change and after you make a change. Did adding contextual retrieval actually improve the score on your hard questions? Did implementing self-reflection reduce hallucinations on that specific set? Without that data, you're just guessing.
You need objective proof that your changes are actually helping.
Yeah.
Crucial.
Okay.
And the third trap, this one seems particularly important for user-facing applications.
Yeah, the third trap is critical. Forgetting about latency. A super smart, incredibly accurate RAG system is completely useless if it takes 30 seconds to give the user an answer.
People just won't wait.
They won't, especially in interactive applications like chatbots or customer support tools. You have to consider the speed implications of each strategy. We talked about self-reflective argy, potentially doubling or tripling latency that might be totally unacceptable for a real-time conversation.
So you need to match the strategy not just to the accuracy requirement, but also to the user's expectation of speed. If latency is your biggest problem, maybe you avoid self-reflection and instead focus on things like re-ranking or hierarchical RAG that can sometimes speed up retrieval.
Precisely. It's always a balancing act. Quality, cost, speed. You have to optimize for the specific constraints and goals of your application. Build a reliable system that solves the user's actual problem, not necessarily a theoretical masterpiece of engineering complexity.
So ultimately, the journey from a basic brittle argy to a great production-ready one, it isn't really about piling on more and more complex features, is it?
Not at all. It's about the strategic combination of the right features for your specific needs and having a clear-eyed view of the trade-offs.
It's about choosing your tools wisely.
Exactly. Because knowledge ultimately is most valuable when it's understood and applied correctly. The goal is a system that delivers reliable value consistently.
That's a great place to summarize. Build for value, not just for technical sophistication. Before we wrap up, though, one final thought to leave our listeners with. We talked about self-reflective argog, where the AI critically examines its own answer against the source material to catch errors or fabrications.
Yeah, a powerful technique.
But here's the question. What if the underlying source data itself, the documents you fed into the system, what if that data is incomplete? Or maybe it contains inherent biases? Can any amount of sophisticated AI self-reflection after the fact truly save the final answer if the foundation is built on is flawed to begin with? Beat? That's something to really mull over as you build and, just as importantly, as you evaluate the trustworthiness of your own AI systems.
That's a profound point about data integrity being the bedrock, a really important consideration. Well, thank you for joining us on this deep dive into advanced RGROG.
We really hope exploring these strategies helps you navigate the path from that initial demo frustration towards building genuinely robust and valuable AI applications. Until next time.